Hello ladies, we're moving on to trigonometry now. So just going through some basics which you have probably covered since year 9. You might hear me talking a little bit louder than usual. My son is downstairs on the PlayStation with his friends. He talks really loudly, and last night I'm pretty sure he was playing the Russian national anthem. But anyway, so I might have to pause if it's getting out of control, but let's hope for a smooth video. All right, so here we've got our learning objectives. So Mr. Weingarten has been fantastic in putting together this PowerPoint, and I guess I've been equally fantastic putting together this video for you just to talk through everything. So what the purpose of this slideshow is basically to understand how to apply your trig ratios to right angle triangles and explore the trigonometric ratios sine, cosine, and tangent, which we usually call sine, cos, and tan. And then we've got success criteria. So basically, by the end of this slideshow, you should be able to, or the end of this lesson, you should be able to label the sides of a right angle triangle and to use the correct trigonometric ratio when given a right angle triangle. So just remember, at this point, we're dealing with right angle triangles only. Okay, so first of all, let's just go over how we remember to name the sides. So we refer to the hypotenuse as being the longer side, opposite the, oh, I was trying to get a mouse up. It's not working. Is this one working? Oh, there we go. So this is our right angle here. So we have the hypotenuse. The adjacent is the side adjacent to the angle. So I like to remember that is A for angle, A for adjacent side, and then the opposite is the side opposite your angle. And that's what they're basically saying. So hypotenuse is your longest side length. Oops, let's go back. So there you go, highlighted in yellow. Adjacent side is the side that is next to the given angle. So as I said, A, and your opposite side is the side that is opposite the angle. Okay, good to know. So put into your bound reference. All right, so first of all, let's label all the sides of the triangle as opposite. So opposite to theta, that's what this little sign is. Adjacent, A to theta, and the hypotenuse. Okay, so there's your hypotenuse, your longer side. O is your side opposite your angle, theta, and A is the side adjacent to your angle. All right, so just revising your trig ratios. So we do call them sine, cosine, and tangent, or sine, cos, and tan for short. Okay, so sine of angle theta is given by sine theta. Okay, so sine theta, cosine of angle theta is given by cos theta, and tangent of angle theta is given by tan theta. So this is basically the sine theta, cos theta, and tan theta is just this simplified. All right, so what's the point? So these ratios are used to calculate unknown lengths or angles in right angle triangles. So let's have a look at this one. So sine theta is the length of the opposite side over the length of the hypotenuse. So this is just a fraction, or you could call it a ratio. That's why they're called trig ratios. In this one here, the opposite is 4, and you can see that highlighted in red. The length of hypotenuse is 5, so that's highlighted in green, and you can see it's happened up here, which is awesome. And basically, sine theta is equal to your opposite over hypotenuse. Okay, so the cosine of an angle, or cos theta, we have the length of the adjacent side and length of the hypotenuse. So cos theta is equal to 3, so length of the adjacent side, and you can see that is highlighted in red, over the length of the hypotenuse. So your take-home message is cos theta is equal to adjacent over hypotenuse. Okay, so you need to have this down. So first of all, you need to be able to label your sides opposite, adjacent, and hypotenuse, and also know how your trig ratios work. All right, your tangent of an angle, or tan theta, is the length of the opposite side. So you can see they're highlighted in red, and the length of the adjacent side highlighted in brown. And your take-home message is that tan theta is equal to opposite over adjacent. Now, the good way to remember it, and you've probably been taught this since year 9, is SOHCAHTOA. So if you can remember this, SOHCAHTOA, it'll remind you of what order your sides go in. So the S here is standing for sine, O is opposite, and H is hypotenuse. So that's where the SO comes in. Ka is the cos, and then you got adjacent over hypotenuse, and then TOA, tan, is opposite over adjacent, and then there's another diagram there showing you O, A, and H. All right, so let's just have a look at example 2. So write a trig ratio in fraction form for the following triangle and simplify where possible. So here we have a triangle. It's a right angle triangle indicated by this square in the corner. So label your sides. So the first step is to label your sides. So we want to label them the hypotenuse and the opposite. So we've got the values 14 and 10, so we're labeling them O and H. Second step, find which ratio to use. So that's what this is pointing to here. So if we've got the opposite and the hypotenuse side, we're going to use, opposite and hypotenuse sides, we're going to use the sine ratio. So you can see that O and H is associated with S. Okay, so state the trig ratio. So just write it down. It's always a good idea to write down the ratio because it'll stick in your mind better. So sine theta is equal to opposite over hypotenuse. So put those values in. So you can see that 10 over 14. So sine theta is equal to 5 over 7. Okay, so we're just writing the trig ratio there. We're not actually solving for theta just yet. If you wanted to do it on your calculator, just make sure that your calculator is in degree mode. So prior to what we just did, you could do that by hand, but most of trig stuff is done on the calculator because, yeah, you can't do it it's just too complicated to do by hand. Now, I'm going to show you after this video how to change your calculator or put it in degree mode just in case it's in radian mode. Now, if you do methods as well, or you might also do specialist, you need to remember further you're always in degree mode and methods, and I'm not too sure if you do trig and specialist, but you'll need to be in radian mode. Okay, so keep that in mind. I'm just trying to think what this calculator is actually saying. I can't even see. Okay, don't worry about number 3. That's just a bit of complication. Okay, so your textbook questions now, remember we're just starting trig again. A lot of it will probably just be revision for you. So just questions 1 to 3. Now, I'm just going to pause. Whoops, can we get out of that? All right, so with your calculator, you need to, it doesn't matter, we can just go to add calculator. We want to go into doc. Okay, so remember we're just changing to degree mode, settings, and document settings. Now, there's lots of settings in here, and I probably mentioned a few of them to you before. The angle is what you want on degree mode. So if you're working with methods as well, you'd be shifting between radian and degree mode. Now, if you ever borrow a calculator off a friend to do an assessment task, always check that you're in degree mode before starting that assessment task, because you don't want to borrow a calculator from a friend who does methods and to get everything wrong because you're in radian mode. Okay, other things you might want to know, calculation mode. Exact means you will always get an exact answer, like a third or a fraction as an answer. Approximate means you'll get a decimal answer. So I just leave it on auto until I need to put it on exact, but you guys probably won't need to put it on exact. Now, if you're wondering where your trig ratios are, they're just there under the control sign next to the control button next to, I can't even see that, so small, and there they are. So we've got sine, cos, tan, etc. All right, So I've just looked at the textbook and it's so basic. You would probably be fine to move on to 11B as well, but I'll leave you to do 11A and I might do another video for 11B. All right, bye-bye.